Hello and welcome to this What's New in the GLOBEClaritas release 2025-2-1, which came out at the end of July, beginning of August 2025. So we have a number of new features and functionality in this version of the software. We have a new UHR Seismic statics module for correcting for variations in the cable toe depths and the source toe depths. This module is called HR Statics, which I'll show you some of the module and some results from that processing on a UHR line. We've got some improvements to the new data viewer that's available in the software, so our change to a Python-based seismic viewer. We've got an update to the surface consistent amplitude module, SCAMP, to enable users to use it on marine seismic surveys. A new append module, improved support for the browsers and selection widget for HTML documentation, upgrades to the Tomo 3D application so it now supports 2D geometries without the need to rebin the data onto a 3D grid. And then there's a simple new file cleanup utility .bot, which allows you to basically clean up your workspace, remove some of the hidden files that obviously eat up a little bit of your disk space but aren't necessarily required to be held long term. So I'll basically run through some of those improvements just so you get a flavour for what's new in this version of the software. I will first show you what's the UHR COSA statics module. This is one of the Claritas modules where it handles both the I/O and applying the solution that you're after as well. So HR Statics does all three parts of the processing flow. So we give it a input data set, and because what we're effectively creating is a trace header, we then update the seismic trace header with some new headers that we create as part of the processing flow. And we're using a picked first break header. So what we do is pick the water bottom on all offsets on the shot gather, and then that picked first break time is utilized to sort of understand the variation in the cable depth along the shot, as well as variations in source depth as well along the line. We provide a suitable water velocity. So the default's 1500 meters per second, which is pretty safe. The grid space parameter generally best left to default, but you can muck around. The wave amp and wavelength as well, I would generally default. And then the plot int, we basically create some diagnostic plots as the application runs, and those diagnostic plots can be useful to inform the user as to how good the solution is. If I pull up the help. So in terms of the grid space, that's the resolution of the grid used to model the seafloor. The default value is set to 5 times the shot spacing. So if you make that smaller, it will be a longer processing time, and then larger values will reduce the resolution of the seafloor depth estimate, so may not give you as good a result. And also if you go very small values, then that can cause instability in the estimation process. And then the wave amp is the approximate wave amplitude of the sea waves in meters, which is used by HR Statics for sea surface modelling. So as long as the wavelength parameter is set to a sensible value, this parameter can be set to a value larger than was observed. So i.e. you want to be able to capture everything within the value you set. So if you make it too small, then you'll start missing stuff. So better to make it large. And then wavelength, the approximate horizontal length of the sea waves peak to peak. If this is set too small, the result in HR Statics modelling not being as effective as you'd like. Too large and the static estimates may be underestimated. So be careful with it, but obviously test the default first and then look at what you might want to do based on that. So what I'll do is run this job so you can see what happens as the job runs. So it identifies how many shots you've got, how many channels, total number of traces, and then informs you of the grid dimensions and the azimuth of the data. Runs an initial iteration and will start churning through and use as many iterations as it needs to resolve itself to the best solution it can. So now we've got the diagnostic window popped up. So we've got a plot that sort of shows the channel depth variation from channel 1 to channel 48 in this case, and the amount it's varying from 0 to 1.5, and then we've got our seafloor depth and how that's varying across the survey, and then we'll start getting RMS values populated. What I will do as well at this point is sort of bring up the shot gathers and display and sort of show what you need to do in terms of picking the water bottom. Now I've got a shot gather there, file. I'm going to load the first break times from the trace header. So you can see there that my first break times are tracking the water bottom quite well, not too jittery. I will just zoom in a little bit around that top surface, and again you can see there that generally we're tracking that water bottom time quite well. So the quality of the result out of HR statics really will be dependent on the quality of this first break pick that you've generated. And so what you might notice on far offsets is if the picks begin to degrade, you might see some anomalous statics and the solution not being quite as good on those far offsets, and that will generally be down to the picking of that water bottom. So what you can then look at is using the FBQC application to see if you can tune those first break picks in a little bit to improve them. And what we're working on as part of the next release, the 2026-1 release, is a dedicated water bottom picker for both HR statics and HRD Ghost, so that we can make it more of a batch process, but also make it more robust so that we makes it easier to get a good result out of it that best fits the needs of HR statics and HRD Ghost. So you can see it's continuing to run through, so it's run 4 iterations so far, and it will continue to run iterations, and as you notice, as you run more iterations, it will start updating the plot. So you can see that the RMS plot now is there, so we can see the number of iterations run so far and the RMS value. So we're trying to see that RMS is improving or decreasing, and the channel depth's varying slightly, and you can see this sort of overlaying of the seafloor depth is improving as well. So I'll leave that running. I don't think there's much more to say about that. It'll run as many iterations as it feels it needs. There's no set number. It'll just keep churning away. So what we can do is I can bring up a stack result from an HR statics pass that I've ran previously. And so what we've got is a stack of the data with no HR statics applied. So you can see that the water bottom has a ripple effect to it, which is not what we'd expect to see, and the events below that water bottom are quite broken up as well. And so if we toggle to water bottom, that correction applied, you can see that we've refined the water bottom itself. It's a lot more consistent and coherent, and events that are a little bit broken up and not resolved properly below the water bottom are a lot easier to track and more consistent up to and interfacing with the water bottom. Again, if I take a zoom window across there, so again here on the zoom panel we can see the water bottom prior to the HR statics module. It's got some ripple and undulation in there, and then everything's quite broken up and poorly resolved below the water bottom. And if we then toggle to the resulting HR statics result, the water bottom's a lot more consistent, better resolution on that, and the events below that are better imaged, and certainly once we've picked velocities, etc., that should begin to resolve even more, improve all the way along. Again, go back to the main plot, try rolling, so you can see that with that sort of correction for the variable streamer and source depths, we begin to improve that near surface quite nicely, and also the deeper events down to sort of just above that water bottom multiple are a lot better after the COSA statics, especially these steeply dipping ones which become more resolved and continuous. So we think that's a good result. Close that viewer down now. You can see we're still running iterations through on the HR statics. We go up to 13, so that keeps running through. And then what I will show you also on this one, because we've run passes of HR statics on this before, is if I go to the analysis tool and text header data values, click like that, you can see that we've created a bunch of headers. So we have the static correction for the source, statics corrections for the receivers, that total statics, and then basically what it will do is it will go through, look at the first break times and trying to improve those. So you can see there's a little bit of a improvement on terms of the first break time against that repick that it does as part of the process, and then the adjusted pick is where it would put it after it's applied the total statics in effect. What we can do is we can plot those on the data if we wanted to, or we can actually within this within the SV application we can apply the statics. So we can take the HR statics total and see what happens when we apply that static correction. Again, see as we move that. So a good QC of the data is to basically run through your shot gathers after you've calculated the statics and see what happens to your gathers. If you're starting to see some big disruptions in the water bottom, particularly at far offsets, it probably suggests there's an issue with your first break time picks or your initial picks, and maybe some effort to improve those would be valuable at that point. But as I say, once it's finished, it'll also give us some information about the locations where the worst picks would be. Or again, we can go directly to those shot gathers and check that out and see how bad and whether we'd want to repick the line at that location. So you can see in the log file here, it's basically identified where we have our reverse residual of a value of about 1.81 milliseconds, which is for shot 2233 channel 9. So we could open the data set, go to that shot gather and look at the pick on channel 9 and see why the residual's so relatively poor compared to all those other around it. Adjust the pick if necessary, or if it's just a bad shot or bad trace, we can kill that trace and remove it from the equation if you like. But we think that's a good new solution for our customers working with ultra high resolution marine seismic data, and we'd encourage you to test it out and let us know what you think. Next we'll go on to look at SeisViewer, new Python seismic display application, and just work you through some of the functionality that's been added. So at the moment we're displaying shot gathers on the data set. So what we've done is, in terms of analysis windows, we've added a lot of new functionality in there. Previously, we had some of the simpler frequency spectrograph traces, characteristics, and say the instantaneous amplitude frequency phase functionality, but none of the more complex transforms or the text header data value parameters set up. So we can now run FK spectras, for instance. We can create our FK spectrum, and then we can add a mute to that, so we can decide how we're going to mute. So in this case I'm going to mute outside that. I can show mutes, edit the mute vertices. I can then pick a mute point and move the picks to include or exclude more energy as I need. I can delete a mute if I don't like it. I can click on the invert button to produce effectively an input, output and difference plot, so I can see what the mute's doing. And as I say, if I don't like the mute, I can just click on delete mute and delete it, start again. That functionality is pretty much the same for all the different transform options. So if I click on Talpi Transform XT, change my settings, so analysis settings, I can change the velocity range. That gives me a new one, and again I can add a mute, so I can say mute below, and again I can click on invert to look at the results difference and see how I might want to change it. And then if I want to, I can say show mute, and I can edit the mute vertices and change the mute however I might want to, and sort of adapt the mute. Or if I just decide the mute's not very good, again I can click on delete mute and remove it. So now we've got the Tau-P transform options, XT and FK based Tau-P transforms, parabolic radon transforms in there as well. Radial trace transform is available. Autocorrelation zoom's been added. And again, we can change the settings in here and make the window longer. Just to confirm, we've got frequency spectra traces, graph, characteristics, and then the text header data value. Click on there, and that will list not only used standard trace headers, so those within the 240 byte trace header, the standard Claritas names, but any extended trace headers as well, so that you can review those. We've also added the capability for header overlay settings, so we can select a header name. In this case, I can say RMS amplitude, for instance, scalar, color, whatever, and display that over there. I can also select another header, so maybe CDP trace, apply that, and then I can play around with the scalar, and you can start seeing. So you can plot over header overlays as you could in the existing viewer. For the next release, we'll add to this functionality to allow users to graph above the seismic, so create a graph display above the seismic, and that will be controlled from within the same parameter form. You'll have a toggle switch effectively to say plot the trace header as an overlay on the seismic or plot it as a graph above the seismic. That'll be coming as part of the next release. And then we've do remove header overlays. We've got one of the pre-existing hardwired header overlays still set, which is the offset overlay, and if I click on that, see again we have a refractive velocity. We can set a color and a line width, so we click apply, and that overlays our offset header. We've kept that one because of the requirement to get it overlaying properly with the refractive velocity, so we just made it simpler by having a default set. Other ones we've removed, but they're relatively easy to recreate. So use this down and restart the seismic viewer, take a stack display, and then if I want to overlay settings, if I want to overlay the stack fold, I select the horizon header, time offset 0, time scalar 1, and click over that. So that's overlaying the velocity. If I multiply that time scalar by 10 to make it a bit bigger, then you can see that basically we're at 60 fold on this data. If we divide it by 10 effectively, then we can see that 60 fold. So that's the header overlay for stack fold. If we want that, just plot the horizon header as you want. We can also play around with how the line style we're using, full, dash, dotted if we want. Marker style, we can also add in crosses, boxes, horizontal tick or vertical tick, if that makes the view look nicer. And for things like coordinates and offsets, we can also choose to apply or not apply the coordinate scalar if we want to. And also for those where we've got values that are going positive to negative, we can also make it display only as absolute values. So there's lots of functionality to play around with. Sure, I'll just remind you of a few of the other things. So process function now allows you to add simple processing in there. So in this case, we would apply a butterfield and AGC to the window, and other options we have there are the ability to add a geometry into the seismic header. So if we're looking at gathers, we can add geometry, balance, debias, FD filter, NMO, if we're looking again at pre-stack gathers, phase rotations, and static corrections if we want to. So there's a nice amount of processing capability there, and we can also update settings for any of the analysis windows. And if something's gone wrong or we're not happy, we can reset all the analysis window settings to the default values just by selecting that option at the bottom there. We encourage people to continue to play around and use the application and give us feedback on what they think is good, what they think could be better. That would be appreciated. I'm going to quickly talk about the append module, just briefly an overview of it. We do that easiest by going to the module help. So the aim of the append module is basically to give users the capability to merge two data sets together, but in time. So you can read a data set in and then add another data set to the bottom of the trace. We had that as a request from a user who'd got a data set that they just needed to tag on us an additional part of the wavelet that had been recorded separately. So it's quite simple. So in essence, we read the data in and then we supply a disk file in here, which is the data that's going to be appended at the bottom of the trace. We can define the primary and secondary key that we're going to append based on. So it's similar to reread, but just adding the additional data to the end of the trace. And let's just quickly get up the release notes. So that's it. So surface consistent amplitude. We've added the capability to use the SCAMP module as part of a processing flow for marine seismic data, and I'll again show you the job flow and the options around that. So again, SCAMP is a module that handles input and output, so it reads in a data set and outputs a new data set with the SCAMP or surface consistent amplitude corrections applied. So if you want to apply it to marine data only, we use the revnr parameter. And again, if I pull up the help documents, typically for land data we do shot receiver all or the rev option. So the rev and the revnr option are basically just to correct for receiver only, whereas obviously surface consistent amplitudes on land data you try and correct for shot and receiver, or possibly all 5 components of it. And then I can show you the result of that application on some seismic data. So data sets in. So I have our seismic data before and after SCAMP. You can see our input data. So this seismic line had an interesting acquisition in that it was 1 meter receiver interval at the start of the line up to channel 24, and then from channel 24 to 48 it was every 2 meter. What I've done with this data is interpolated traces in between channels 25 to 48 to make it a 1 meter group interval all the way across the line. But you can see that the amplitudes, whilst okay, are not perfect on the interpolated traces. So we can use SCAMP basically to smooth out that slight amplitude anomaly on those interpolated traces, and it does a very effective job. And again, if we go to the analysis window and look at frequency spectra traces, so that's the data prior to interpolation, and that's after SCAMP, post interpolation, and then after SCAMP's done its job in terms of improving or resolving that amplitude discrepancy. So it works quite effectively on this marine data. I think it's a good addition to the options within Claritas in this new release. Improved supported browser selection widgets for HTML documentation. So if you go to the Claritas launcher, go to Tools and User Preferences, and at User Preferences you'll see there's a little widget comes up. It gives you an option as to how we launch the help documentation. The options are browser, TextWin or Qt help. So if we stick with browser, and then the options that we've got in here are a simple lightweight Claritas browser, and then more typical browsers that are available to Linux and Windows users worldwide. So Firefox, Chromium, Google Chrome, Opera, Brave and Conqueror. So Firefox is typically on Linux OS, is generally available, but I can also provide information on installing Chrome, Google Chrome if required. And we've cleaned up and got rid of some of the older browsers that no longer really are available to anybody. And as you can see from here, we are using Google Chrome to display the HTML version of the help in Claritas. So next thing I'll discuss is the Tomo 3D updates. So previously with Tomo 3D you could process 2D data in Tomo 3D to get a refraction static solution and velocity model from it, but it did require you to rebin the data onto a 3D grid, which was a bit of a nuisance. So we've updated Tomo 3D where it now accepts 2D geometries. So we'll add some pics in. geometry file, and that's a 2D geometry to the model. So you see there's capability to just reorientate and make sure that the 2D line is well encompassed within the model bounds that you're setting up. And then we can go to the iterate button and start that iteration. And so initially, because I've not applied a velocity model, it'll ask me if I want to use a 1D velocity model. And I'll say yes for that. And it'll start iterating through and working on that 2D data. So if you want to use a tomography solution for refraction statics on a 2D line, you can do now using Tomo 3D without any sort of additional workflow steps for yourself of having to try and apply a 3D geometry to the data. Again, feedback on what you'd like to see further improvement wise in Tomo 3D over time would be useful. Just let us know. And then finally, we have a new module or new file cleanup utility called .bot. So .bot's a Python-based utility, and basically what it does is it will search through your project directory and look for any hidden files, and basically then define what you want to remove. So again, if I go on this cleanup utility, so we generate a lot of hidden files to help different applications manage and work with the data. So .bot is there to basically go through and identify which hidden files you've got, and then gives you the option to remove only those that are safe or okay to remove. So for instance, if in this project, if I go tools, open the terminal window, .bot -p brv84 v-14 -la. That should list. That's going to list all the different journal files and hidden files in the project. And then I could go .bot -p brv4 v-14 -s to remove those that it's safe to remove. So I'll use the .bot -p br84 v-14s to look at it. So file related hidden files, original files exist, 4, 55, 42, 16. Hidden files, original files do not exist. That gives me a list of those. Other Claritas hidden files, identified, counts, how many directories, how many unused, could remove 174, shouldn't remove 243. It will remove those that it's safe to remove. So it gives you a simple tool to basically go through and clean up your directories and get rid of those files that are not as easy to identify and find, but also safe in that if you're using the safe or the OK mode, it should only remove files that you can do without and are either easy to recreate should you need to, or will cause no harm because the files they're associated with have already been deleted by you because they're no longer required. Again, have a play around, see how it works. Any feedback be appreciated. Obviously, any questions or other improvements you'd like to see in the software, please do contact us on support@globeclaritas.com, and we would encourage you to download this latest stable release and start playing around with the new functionality. Thank you and goodbye.